about your research institute?
Okay, thank you. Yes, so my part of the project was to study the inbreeding that's happened in the flock at ARI. And there's a number of reasons why it's actually of interest for study. Basically, the flock was established in the late 1960s and the 70s, and it's been a closed population since 1988. We know that there was a small number of founders used to actually develop the stock, tens of animals, to actually establish the stock. There's been several large changes in the size of the flock over the years. In terms of inbreeding, the main point of interest though is the scrapie resistance breeding program, which was started in 1988, because it's a known factor for starting inbreeding because of the few number of animals which are resistant, which are used to actually initiate the program. In terms of the program here, it was 2 homozygous animals for resistance and a few heterozygous animals. So we know that that's a definite potential for inbreeding. Of course, we've also had the long-term selection program for milk yield and growth, which again is a factor in terms of inbreeding, which we should consider. In terms of management of the inbreeding over this whole period of the flock has been established, it's mainly been just through the constraint of mating related animals. And of course, this is always based on the pedigree information which is kept. And at least here, we know that it's actually been very good information. The records have been very well kept. And that's also a big aid in terms of studying it. Just to sort of show you what's happened to the flock over the years, you can see it's actually established. There were a few number of animals here, and there was a long period where the flock was actually fairly small. There's actually a number of lambs per year. Then in 1988, this is the start of the breeding program for scoping, and you can see that there's a very large increase in terms of numbers. And this carries on for another period up to about 2000. And again, there's another big jump in numbers, and the actual maximum being here in 2006. And just in the last couple of years, there's actually been a reduction. But there's been a lot of changes, and this does have implications in terms of inbreeding, really related to the actual mating program that was used. So in terms of the objectives of the study, it was to do an evaluation of the inbreeding, which hadn't actually been done previously. We were going to use the pedigree information that was taken by the ARI. We would look at the founder effects and any genetic bottlenecks that have occurred, and also just generate some general statistics for information to carry on with the program. And because of the actual fitting in with this project, with looking at association studies, we had some genotype data available to actually do a comparison between pedigree and genotype data, which is very rarely done, actually. So in terms of the actual analysis, we gathered just under 10,500 records over the whole period of the population. Then we used our software to create the relationship matrix, which allowed us to calculate things like the inbreeding, genetic contributions, relatedness, and then following on from these, we can get the rate of inbreeding, generation intervals, and effective population size. So this is what the actual pedigree looks like. It's very complicated. That's why we need the statistics to kind of come up with something useful from this. And then also looking at the methods for the genotyping. This was 192 animals. These would be taken from the last year of that data, so 2008. We genotyped them with 15 microsatellite loci. We used multiplexes really to reduce the costs. So this is really just to cut down on the amount of sequencing we did. And again, we used our software to go through the analysis and looking at basic statistics like heterozygosity, number of alleles, the inbreeding, and finds history. So this is, I think you've seen already this morning, this is just to show you the distribution of the microsatellites. They were sort of spread right through the genome, so there's 13 chromosomes we actually had markers on. And these were taken from a list by the FAO, which are recommended for using these types of population studies. So in terms of, this is results from the pedigree analysis. this is just to show you how much sort of information we actually have. This is the present on this side, and this will be the past. So we're actually looking at a high proportion of information up until about 10 generations ago. And then obviously the most amount of information we have is from now, because this is all the records have been kept since the start of the scraping program. These animals up here, we really don't have much information on, just due to gaps in the records. In terms of actual numbers of generations, the longest pedigree we have is 19 generations, which is very, very good. So this is the actual inbreeding in the stock over the whole period. This is the actual mean of inbreeding values in each year. And here, this is the expected inbreeding. So this is the sort of the ideal condition if there was completely random mating, no influence on the number of parents, this sort of thing. So you can see that, well, there's a sort of a minor aberration in the beginning there, which is due to one very inbred individual which was recorded. Probably either a mistake in the pedigree or a mistake in the breeding, which has led to that little peak there. But you can see from the beginning of the scraping program is when the inbreeding starts, and it's quite variable in places, which suggests that it's something to do with the breeding, the numbers of animals being used, something in the breeding system which is causing this. And also, as you see, as the population, this matches with the largest number of lambs being born, is when you actually get the most rapid increase in inbreeding. Which again suggests there's something within the system of breeding which is actually increasing the rate of inbreeding. And I should say the maximum here, it's about 4.5% in breeding. If we look now, this is actually the contributions, the genetic contributions of the sire animals. This shows us where the actual bottleneck occurs and how, basically. This peak here represents the first year of the breeding project for scraping, where there were only a few males being used, so their genetic contribution is very high. Following on from that peak, we actually get several more smaller peaks as the effect of this initial bottleneck is being diluted. So every 2 years, which corresponds to the generation interval of the sires, we get another peak. And this is where the animals which are related to those initial resistant animals are being used preferentially in the breeding program. We then get another sort of larger peak here, which is about 1999, and this relates to, again, a shortage in the number of males that were produced. So the fewer males, the higher the contributions of each individual. And then again, that has another peak following on. So we can see there has been a genetic bottleneck, and it has had the effect of starting inbreeding. If we then look at the genotyping data, okay, we used 15 microsatellites. These are sort of the mean numbers here. We had relatively good microsatellites, a high number of alleles, a reasonable effective number of alleles, which is basically a measure of how varied the allele frequencies are, how balanced they are. So we could say that the markers were actually fairly good. In terms of actual heterozygosity, you can see there is a reasonable difference between the observed and expected heterozygosity, which indicates that there is inbreeding. This is our estimate of inbreeding from the marker from the heterozygosity, which is about 0.59, which is slightly higher than we had for the pedigree, but this is what we would expect, just because of the inaccuracy of using markers. If we actually do a comparison of the two methods using the pedigree and the markers, we actually have some very good results here. So from the pedigree we have 0.045 for the inbreeding, and if we use the molecular coancestry as a parameter in our inbreeding estimate, we actually bring this down to 0.0437, which is actually amazingly close, I think, to the pedigree. Coming from these values, then we can get a rate of inbreeding per generation about 0.6% from the pedigree, and just under 0.5 for the markers. This gives us an effective population size of between 75 to 100. And in terms of relatedness, here we have 0.58 from the pedigree information, and we would expect the molecular, actually should be kinship there, there should be molecular kinship would be about half. So we have 0.6 and 0.7, again, very close match between the data, between the two methods, I should say. So the conclusions we can draw from this work is that there was a definite genetic bottleneck at the start of the scraping program, based purely on the number of animals that were available. In terms of the progress of the inbreeding, it's been fairly slow. 0.6 per generation is actually quite normal and well within the sort of parameters we would expect for a small population. So now we're looking at 10 generations of breeding, and the inbreeding is at 4.5%, which again is very normal, very consistent with other populations and farm populations. We can also see that there's some minor bottlenecks, and these are caused by the numbers of parents which are being used as a constraint on occasions, and this is actually visible in the data. And this would be something to avoid if we were going to, thinking long term. There's also some other things which should be done long term in order to keep the inbreeding stabilised and not to increase much further. And there's various measures we could do to do that. And the other main conclusion we can draw really is that the use of the microsatellites was actually very, very good, and the data we had was very useful, very comparative to the pedigree information. And this means that we could use it to characterise flocks which haven't had pedigrees recorded, which is usually most commercial flocks, certainly in Cyprus. And so we have a method now to actually evaluate these flocks if we needed to. So again, you've seen these names before actually. I'd just say